This video is about malware. As we will see, the term malware refers to any software that has a malicious action. Malware can stand alone or be injected into legitimate software. Malware targeting system integrity generally has a replication mechanism, while malware targeting data confidentiality has no replication mechanism and aims to remain undetected. Malware can also allow an attacker to gain complete control of the infected computer without the legitimate user of the computer even being aware of it. So let's review the different types of malware and say a few words about their prevention. The term malware was invented in the 90s as a contraction of malicious software. Before the 90s, the term virus was used instead as a generic term to denote malicious software. Nowadays, virus, as we are going to see, refers to a special type of malware. Malware always installs on a computer without the user's knowledge. There are different types of malware, and as we are going to see, malware differs from one another by its mode of distribution and by its malicious action that is called the payload. The first and the oldest type of malware is virus. A computer virus is software hidden in another harmless program that can produce copies of itself and insert them into other programs or files. So viruses are defined by the fact that they are software injected into legitimate programs and that they have a replication mechanism. Because of this replication mechanism, viruses can spread uncontrollably. Viruses generally target the integrity of the host system, very often destroying data. Sometimes the replication mechanism alone is the payload. My point is that if the virus replicates itself in the operating system files, the system can become unstable. So it might not be necessary to have a payload separate from the replication mechanism if the goal is only to corrupt the integrity of the system. A computer virus consists of several elements. First of all, the virus has a search function to locate new files to infect. Next, the virus has an infection function which consists of injecting the virus into a new file. The search routine and the infection function therefore constitutes a replication mechanism. The virus also has a trigger function that waits for a special event to activate the payload. And finally, the virus has a payload function that executes the malicious action. There are different types of virus. A resident virus will load its replication module into memory detached from any host program. Therefore, such a virus has a very high replication capacity. Since the replication module resides in RAM, it is basically constantly active. A macrovirus is written in a macro language like Visual Basic and embedded into documents, very often Microsoft Office documents or PDF documents. Such type of virus becomes active when the document is opened. A boot sector virus targets the boot sector or the master boot record of the host's hard disk drive or removable storage media. This type of virus is becoming increasingly rare because modern BIOS have built-in protection against it. Getting rid of a boot sector virus can be very difficult. An email virus uses the email functionalities to spread, that is, to send emails with malicious executable attachments. However, an email virus is in fact a kind of worm, as we are going to see later. By the way, modern malware can spread in different ways, can include several types of malicious actions. In fact, it's not always easy to classify malware into a given category. So let's say a few words about the infection function of a virus. In fact, most executable files are sparse, that is, there are gaps between the code and the data. Once the target file has been found by the search routine of the virus, the infection function inserts the virus code in the empty gaps of the target file. Checking the file size is therefore not an option for virus detection. Now the hash of the file content changes, of course. So calculating the hash of the file content and checking if it has changed can be a solution to detect a virus infection. Virus can be executed before or after the legitimate code. This depends on how the virus hijacks the program entry point, which is the pointer to the first instruction. In our example, the virus is executed before the legitimate code. As you know, antivirus software can detect virus and any kind of malware. However, viruses use various defense strategies to defeat antivirus software. These strategies are referred to as stealth techniques. First, a virus can intercept the request to read the infected file sent by the antivirus software. This is, of course, requires the virus to have a high level of privileges. So it depends on the infected file. It should be a system file. A virus can modify its own code at each infection, making detection by a signature-based antivirus software more difficult, but not impossible, because it is actually difficult to rewrite the virus so that there is no similarity between the original code and the rewritten code. And by the way, when I say signature here, we will talk about it later in this video. I simply mean a code pattern, a specific code string if you want. It has nothing to do with the concept of digital signature. A virus can encrypt its own code, leaving a cryptographic key, a decryption module, and the encrypted code. The encrypted code is never constant because encrypting the same content several times never gives the same output. This is a basic principle of modern encryption. However, the decryption module never changes. Therefore, it's still possible that the antivirus detects the virus by using signatures. A polymorphic virus is an encrypted virus where the decryption module is modified on each infection. So a polymorphic virus combines encryption and modification. Detecting a polymorphic virus by using signatures becomes unlikely. These stealth techniques are used not only by viruses but by any kind of modern malware that aims to evade antivirus software. So we have just seen what a virus is. And in fact, the concept of a virus, as I have described it, malicious software that infect existing legitimate software through a replication mechanism, that scheme in fact is declining. Why is that? It's difficult to know. One thing is that it is more difficult than before to infect software. Antivirus software has also improved the detection of infected files. So in the second part of the video, we will see other types of malware, namely the worm and the Trojan horse. Worms propagate as a standalone process through a communication channel, and Trojans aim to remain undetected, so they don't try to replicate or propagate. So what's a worm? A computer worm is a standalone process that actively spreads over the network to infect other computers. Computer worms rely on vulnerabilities in networking protocols to propagate. Typically, a worm running on an infected computer will scan ports of other computers in search for a specific vulnerable network service. In general, a worm exploits a specific vulnerability in a specific network service. Like viruses, worms can spread uncontrollably. Worm can slow down a private network by consuming the local bandwidth, And nowadays, attackers have the tendency to use internet worms to install other malware like Trojan horse. They use the propagation mechanism of the worm to spread malware that cannot propagate on its own, like a bot or a ransomware, which are both specific types of Trojan horse. Some worms can use the email or the messaging application of the infected host to spread. An email worm propagates by sending emails to email addresses found in an email address book. The worm simply attaches itself as an executable to each email that it sends out. An instant messaging worm propagates by sending messages to contacts found in the contact list. The worm includes a link to download itself in each message that it sends out. We'll see later in this video some examples of computer worms. But before that, let us present the Trojan horse. A Trojan horse, or you can say Trojan, is any malware that is disguised as legitimate software. Trojans can spread in different ways. By using social engineering as an email attachment or as a malicious link offering to install a program to download music or videos. Trojan can also be embedded in free downloadable software like illegal cracked games. And Trojans can also be injected in HTML pages through a cross-site scripting attack. Trojans are distinct from worms and viruses in two ways. First, Trojans are designed to go undetected. And this is why they do not have a replication or a propagation function. I think this is one of the most distinctive characteristics of a Trojan. Second, they often try to steal sensitive data. However, they can do any other malicious action. This slide describes the process of installing a Trojan via social engineering. The Trojan is sent as an email attachment to the target victim. The victim is not suspicious and executes and installs the Trojan. Once it has infected a computer, a Trojan can contact a controller, giving access to the infected computer to the attacker. Note that an alternative to contacting a controller is to set up what is called the backdoor, that is a network service to which the attacker can connect. The controller, that is the attacker, has then unauthorized access to the infected computer and can potentially upload and install other malware. Very often the attacker will first upload a rootkit. Rootkits are a set of tools to conceal malicious activities like preventing the Trojan from being visible in the system list of processes, for example. Other types of malware that the Trojan can install are specific types of Trojan like keylogger, ransomware, bots, and so on. So let's quickly review this malware. What's a keylogger? A keylogger is a Trojan that captures the key struck on a keyboard without the user noticing. Keyloggers are most often used for stealing passwords and confidential information. How do they work? Well, first the user enters his password to authenticate to a distant website, for example. Then, the password is encrypted and sent over the communication channel. The keylogger captures the password while it is being typed by the user, that is, before encryption. So, encryption is therefore not a protection against keyloggers. And we should mention that it's because of keyloggers that most banks have replaced the traditional username password with some more advanced authentication techniques like typing a PIN code with the mouse. One thing about the privileges held by the keylogger, If the keylogger has been injected in a web page by a cross-site scripting attack, then the keylogger will be able to intercept the keys struck within the infected web application only. This is because of the sandbox mechanism protecting the host computer and the same origin policy protecting other web applications. Now, if the keylogger has kernel privileges, that means it was not installed by a cross-site scripting attack, it was executed as a system process, then in that case the keylogger can intercept all the keys struck on the keyboard, regardless of the application where the keys are struck. A ransomware is a Trojan that encrypts user data with the RSA algorithm. In fact, data is encrypted with a symmetric cipher and only the symmetric key is encrypted with RSA. But I won't go into details. Think that the user's data are encrypted with a public key and that only a private key can decrypt the data. And of course, the attacker has the private key. So the attacker will send you the private key on condition you pay a ransom. And very often the payment has to be in Bitcoins. There is also an expiry date for the payment. After that date, you can no longer recover the private key. If one day you are infected with a ransomware, I would be inclined to tell you not to pay because paying the requested fee does not guarantee that the attacker will send you the key. Simply report the matter to the police, but of course you're the best judge of that. One thing I want to mention about ransomware is that the cloud can help you mitigate the effects of ransomware. However, backing up your data in the cloud is not enough, because if your data becomes locally encrypted, then the synchronization mechanism will back up your encrypted data in the cloud as well. Unless you disconnect the computer just in time, just before the synchronization takes place, which is unlikely. Now, if the cloud supports versioning, then in that case you can restore the previous version of your data before encryption. And if you do not see clearly what the cloud supporting versioning is, simply think about GitHub. GitHub is the most well-known example of a cloud system that supports versioning. Finally, last type of Trojan I would like to mention is the bot. A bot is a Trojan specialized in malicious, repetitive, automated tasks like flooding a target site with requests within a DDoS attack or sending large amounts of spam. A malicious bot generally belongs to a botnet, that is a distributed network of bots, all under the control of a single attacker. So now you know about virus, worm and Trojan. Today Trojan is by far the #1 malware. Viruses have almost disappeared and worms are very often used to distribute Trojans. One thing also I may not have stressed enough is that modern malware has polymorphic capabilities, which makes it difficult to detect, especially Trojans, which are designed to remain invisible. Before we look at how to prevent a computer from being infected by malware, let us review 4 historical malware programs that caused a lot of damage. Here are 4 famous malware. I chose these 4 malware because each of them is historical malware. That is, malware that was very different in its conception from previously known malware. The Morris worm. The Morris worm was the first malware to gain media attention. It was created by Robert Morris, a student at Cornell University, definitely a bright student, and a student who knew about system programming and network programming. Morris claimed that his objective was simply to count the number of computers connected at ARPANET, which is the ancestor of Internet. However, the Morris worm caused the denial of service to 10% of the 60,000 computers connected to ARPANET. To give you an idea, think about a worm that would cause a denial of service to 10% of the computers connected to the modern internet. It would be like a devastation. The Morris worm was a pretty sophisticated piece of malware. It exploited several vulnerabilities in the Unix system. At that time, there were only Unix systems connected to ARPANET. So I have listed here some of those vulnerabilities. In addition, the Morris worm included some defense mechanisms to protect itself from being killed by an administrator, for example. And it is one of these defense mechanisms that proved fatal to the infected computers. Indeed, one of these mechanisms was to replicate itself several times on each infected host. However, this was done in an uncontrollable manner and caused a denial of service to the infected host. Zeus is a landmark Trojan. It is more a malware package than a simple standalone malware, since it can be used to carry out multiple malicious tasks. It has been very often used to steal sensitive information by keylogging or form grabbing. Form grabbing is the equivalent of keylogging, but for leaking HTTP forms in the clear before they are encrypted and sent to the connected website. Once installed, Zeus connects to a controller, allowing the attacker to access to the infected computer. Zeus can be used to install other malware like ransomware. Zeus is polymorphic malware, very difficult to detect by antivirus software. Zeus is distributed by using social engineering most of the time. Zeus is such a reference Trojan that it is the base of many current Trojans and is still posing a threat today. Zeus, like many Trojans, can be bought at the underground market of the dark web. Stuxnet. Stuxnet was an extraordinary piece of malware. In fact, it is the most sophisticated malware ever conceived. It had an unusual size of 0.5 megabytes, which is big for malware. Technically, it's a worm with a destructive payload. It exploited 4 zero-day vulnerabilities in the Windows system, which is also very unusual. The payload was to destroy the centrifuges of Iranian nuclear power plants equipped with a specific Siemens industrial control system. That was the first time that malware was used to destroy hardware. And what hardware? I think you have understood that Stuxnet was not programmed by a script kiddie. Stuxnet was developed by American and Israeli intelligence agencies. So how does Stuxnet work? Stuxnet enters the Iranian nuclear facilities network via a USB stick. Is it through a baiting attack? Most probably, but I don't know exactly. It then proceeds to infect all computers running Microsoft Windows on the network. It's a worm, I remind you. Once installed on a machine, it searches whether the computer is connected to a Siemens industrial control system. What is this? Such a system is used to run high-speed centrifuges that help to enrich nuclear fuel. If the computer is not connected to such a system, Stuxnet does nothing. If the computer is connected to such a system, then Stuxnet first attempts to update itself through Internet. It then compromises the target system logic controllers. These are proprietary Siemens systems which have nothing to do with Microsoft Windows. So this also shows the sophistication of that malware. Then it takes control of the centrifuges, making them spin to failure. And meanwhile, it provides false feedback to human controllers as if everything is working normally. Over a few years, about 20% of Iran's centrifuges were destroyed without the Iranians understanding what went wrong. However, devil is in the details. I told you that Stuxnet periodically updated itself. Well, an update of the code introduced a bug causing Stuxnet to become unstable and shutting down computers. So, the Iranian contacted a small Belarusian company specialized in cybersecurity, and Stuxnet was discovered on June 2010 by an engineer of that company whose name is Sergei Ulasin. If you have not watched it yet, I strongly advise you to watch that documentary on YouTube. It's better than a thriller. It tells you the story of Stuxnet. And if you're interested in technical details, then you can refer to that report from Symantec. It was written by Symantec researchers who reversed the Stuxnet code. Last malware we are going to see. Mirai. As computers become more and more protected, the current trend is to carry out attacks from zombie objects. I am sure you have all heard about the Internet of Things. The things or the objects are connected devices like webcams, various types of sensors, automation systems, and so on. And the last malware I want to talk about is this Mirai. Mirai is a worm that infected Linux-based vulnerable objects connected to Internet. Each infected device turned into a bot under the control of a remote attacker. The Mirai botnet consisted of hundreds of thousands of infected devices. So I said Mirai is a worm, okay, but because it's a malware that propagates through the network, okay, so it's a worm, but the payload of that worm was to turn each infected device to a bot. And that's why I'm also talking about the Mirai botnet. On October 21st, 2016, attackers controlling the Mirai botnet launched a DDoS attack against the DNS infrastructure of the DNS provider Dyn. Dyn is a DNS provider that is used by some major internet companies. And as a consequence, half of the internet in the US was paralyzed, mostly the East Coast. And I can even tell you that I live in French Polynesia and we are directly connected to the US, so we depend on the American part of the internet. And I remember that day we also experienced some disruptions. And there have also been disruptions to the internet worldwide, not only in the US. So let's take a closer look at how Mirai works. Actually, Mirai is a very simple piece of malware. It's probably even simpler than the Morris worm, which was a very old malware. First, the worm Mirai scans the internet from random IP addresses. If it finds an object, it tests default passwords. So, the vulnerability exploited by the worm is simply the device with a default password. It's not really technical. If it manages to connect to a new object, it infects it so that the newly infected device can in turn scan the internet. It then sends a notification to the report server under the control of the attacker. The report server connects to the newly infected object and injects it with a payload, turning the object into a bot ready to participate in a DDoS attack. So the payload that consists in turning the device into a bot is not transported by the worm itself, it's uploaded by the report server. The attacker then launches a DDoS attack against the Dyn DNS infrastructure by using all the infected devices. The attacker contacts the infected devices with the intermediary of the so-called command and control servers. This is a typical DDoS attack scenario using a botnet. So what were these internet objects that were used by Mirai? Mirai devices were mostly webcams, home routers, and even baby monitors. Mirai was the first malware program to exploit connected objects for a massive DDoS attack. The source code of Mirai was published on hack forums, and as you can guess, it has been adapted to other malwares. So I hope the description of these 4 historical malware has given you a sense of what malware can do. I find the fact that personal computers can be infected by malware very disturbing. Although I teach computer security at the university, I wouldn't swear that my own personal computer is free of malware. So what can we do as simple users of a personal computer? What can we do to limit the risk of our computer being infected? There are some solutions that rely primarily on the use of antivirus software and certain precautions to avoid being the victim of an attack, such as a phishing attack that would install malware on our computer. In the last part of this video, we will briefly describe solutions to reduce the likelihood of malware being installed on our personal computer. Malware prevention requires several steps. The first step to protect your personal computer is updating the operating system whenever possible. Malware is very often installed through a software vulnerability, or malware will use a software vulnerability to carry out its payload. So really the first thing to do is to keep updated the operating system, because operating system updates patch newly discovered vulnerabilities. The second step is installing antivirus software. Keeping the operating system updated and installing and keeping updated an antivirus software are the 2 basic steps to protect your own computer. Now, the Mirai worm has shown us that connected objects can also be infected. So the default username password of these objects should be changed, including the default username password of your home router. Malware prevention also relies on your online behavior. It is therefore important to be careful when downloading software, to choose safe passwords, to avoid clicking too quickly on links in emails or text messages, and so on. In the previous slide, I mentioned the antivirus as an important protection against malware. So let's give more information about this antivirus. Antivirus, whose name should have been anti-malware, uses several strategies to detect malware. For non-malware, the antivirus uses a signature database. A signature is a string of bytes characteristic of the malware code. If a program containing a non-signature is found, then that program is quarantined. And keeping the virus definition database up to date is crucial. However, as you most probably know, this strategy has its limits, as modern malware programs have polymorphic capabilities and are regularly updated by their designers. But still, this signature database is very important to detect common malware with non-polymorphic capabilities. Regarding unknown malware or polymorphic malware, the antivirus uses heuristics, which will mainly monitor the process behavior. One example of such heuristics could be to identify as malware a process updating the executable code of several programs on the disk, or another process opening a network service and receiving suspicious connections. Analyzing the behavior of processes to detect malware is a strategy that has recently improved with new behavioral models learned from machine learning techniques, for example. Nevertheless, no antivirus is perfect, and modern antivirus still have difficulty to detect unknown malware. As a matter of fact, I encourage you to read about the Project Sauron. Project Sauron was a sophisticated Trojan that went undetected for several years, although it had infected many government organizations throughout the world. Another problem with the heuristic approach is that it leads to false positives, that is, legitimate programs that are falsely detected as malware. So this is the end of this long video about malware. So you have learned the different types of malware: virus, worm, and Trojan. I gave the description of 4 historical malware, and I talked a little bit about strategies to prevent malware. There is a category of malware I didn't talk about, which is a specific type of Trojan, and which is sometimes referred to as privacy-invasive software. In this category of malware, you will find spyware that gathers information about your browsing activity, for example. You will also find adware that pushes unwanted advertisement to your screen in a way or in another. These malware programs are not very dangerous, but they are malware that should be eliminated.